Hello everyone, my name is Stefan Mabry, and I'm a PhD student at the University of North Dakota. Thank you for joining me today. We'll be discussing taxonomy and measurement criteria for automated testing frameworks in healthcare interoperability. Specifically, I'll present a structured approach for evaluating and optimizing automated testing efforts in healthcare systems, focusing on improving reliability, patient safety, and operational efficiency. Our perspective centers on the challenges faced by large healthcare systems, where seamless data exchange, regulatory compliance, and system resilience are critical but increasingly complex due to the scale and diversity of connected technologies. By the end of this presentation, I hope you'll gain insights into why healthcare systems require a strategic approach to automated testing, how to categorize and evaluate testing methods tailored to healthcare-specific needs, and the role of prioritizing high-risk areas like clinical workflows and APIs for maximum impact. Let's get started. Some background on the state of data exchange in the healthcare industry. Healthcare data is growing faster than any other industry, driven by the complexity of its ecosystem. Imagine a healthcare system with countless applications, each built by different vendors, running on different technologies, and designed to serve unique needs. These systems need to communicate seamlessly, but the diverse configurations create a huge challenge. Integrating these systems is like trying to fit together puzzle pieces from different puzzles, all while managing the unique demands of each hospital or clinic. At the same time, healthcare data is exploding. As of 2020, it accounted for 2.3 zettabytes and is growing at an astounding rate of 36% annually. But even with this vast amount of information, much of the data is fragmented or unstructured, making it difficult to access, standardize, and use effectively. And with all this complexity and data growth come significant risks, particularly for healthcare organizations. The most critical risk is to patient safety. If systems fail to communicate accurately or data isn't accessible in real time, the consequences could be life-threatening. For example, imagine a scenario where a medication allergy is documented in one system but not properly transmitted to another. Such oversights can lead to dangerous medical errors. Healthcare organizations are also under immense operational pressure. As costs rise and resources remain limited, there's a growing need for efficiency. However, poorly integrated systems create inefficiencies, forcing clinicians to spend time reconciling data across platforms instead of focusing on patient care. This not only increases clinician burnout, but it also strains already stretched budgets. And finally, there's a financial and compliance burden. Interoperability failures can lead to regulatory penalties, lawsuits, and damage to the organization's reputation. In an industry where trust is paramount, these risks highlight why robust and reliable data integration strategies aren't just a technical priority, they're a strategic imperative. Here are some key concepts you should be familiar with through this presentation. Healthcare interoperability involves the seamless exchange of data across systems, which can be categorized into three levels. There's foundational. This level allows one system to receive and exchange data with another, ensuring basic connectivity. There's structural. At this level, the structure and format of the data are preserved as it moves between the systems, maintaining consistency. And then there's semantic. This is the highest level of integration, and it enables to not only exchange data, but also interpret and understand it using standardized terminology, ensuring the meaning is consistent. Data is integrated into care processes, business operations, and patient workflows. Achieving this is the ultimate goal, but it remains challenging. Additionally, electronic health records are systems that store patient information, playing a critical role in interoperability efforts. Key standards facilitating interoperability include HL7 and FHIR, which determine the structure and exchange mechanisms for healthcare data today. Other terms you should be familiar with are data standardization, which pushes data to conform around an existing standard. Structured data that is well organized, and while unstructured data is like clinical notes, they lack defined formats. And finally, APIs are your programmer interfaces, which include HL7, Fire, CCDA, and DICOM. So that brings us to the question at the heart of this presentation. How can healthcare organizations strategically allocate limited resources to select and deploy the most effective automated testing methodologies for maximizing impact? Healthcare systems today face an unprecedented level of complexity. They must integrate diverse technologies from electronic health records to medical imaging systems and wearable devices, while maintaining compliance with strict regulatory standards. Add to that the frequent system updates, limited budgets, and high stakes of patient safety, and now you have the landscape for where the margin of error is incredibly slim. This question highlights a critical challenge. Resources are finite, but the risks of failure, such as disruptions to clinical workflows or patient harm, are enormous. The goal is to align testing investments with the areas that will deliver the greatest return, particularly in terms of safety, reliability, and operational efficiency. To address the challenges of interoperability in healthcare, automated testing has become a critical tool. Why? Because it enables us to validate reliability across interconnected systems. In a healthcare ecosystem where a minor failure in data exchange can have significant consequences, ensuring that systems consistently and accurately communicate is non-negotiable. Automated testing also tackles the issue of resource constraints, which is a persistent problem for healthcare organizations. With limited budgets and competing priorities, we can't afford to test everything, everywhere. Automated testing helps us prioritize efforts based on the criticality of different APIs, focusing on the areas where failures could have the most severe impacts, whether it's patient safety, compliance, or operational efficiency. This approach allows healthcare systems to not only reduce errors, but also optimize the allocation of their finite resources, delivering the most value where it matters most. Automated testing in this sense isn't just about efficiency, it's about building a foundation that is reliable, scalable, and safe for healthcare technology. That is, if health systems invest in the right automation tools in the right places. By focusing resources on the right interoperable components and automating with effective testing methods, we can ensure seamless interoperability and improve patient outcomes, meet regulatory compliance, and enhance the operational efficiency. This approach allows us to strategically allocate finite resources for maximum impact. This slide highlights the key technical challenges that must be addressed for effective healthcare interoperability. There's data, which is the healthcare ecosystem deals with fragmented and unstructured data spread across various platforms. Even with the standards of FHIR, HL7, and DICOM, the technical complexity of healthcare data complicates data exchange and integration, making it harder to drive semantic interoperability. There's the updates. Frequent system updates and releases, such as quarterly EHR updates or biweekly API changes, introduce complexities in maintaining seamless workflows. Each update risks introducing errors and breaking existing interoperability. And then there's the risk. The potential for downstream failures disrupting critical workflows is significant. For instance, a failure in one API could cascade, affecting clinical operations or even patient safety. And then there's scalability. Testing methodologies must adapt to scalability demands of the healthcare systems. As data grows and workflows evolve, testing solutions must keep pace to ensure efficiency and reliability. These challenges underline the need for structured and strategic approaches to automated testing to ensure healthcare systems remain resilient, reliable, and interoperable. Healthcare and other industries, they employ a variety of methods of testing that can be automated to perform interoperability testing. And it's anticipated that new methods will emerge as semantic interoperability continues to evolve. These methods are listed here to support the development of a taxonomy and measurement criteria, enabling the evaluation of both current and future testing approaches. It's intended to be illustrative and is not intended to be a comprehensive list. On this slide, you'll see examples of these strategies. For instance, functional testing ensures core system functionalities perform as expected, validating processes like retrieving patient data or transmitting lab results. Another, perhaps less conventional method is called chaos testing, where intentional faults or disruptions are introduced into the production environment to observe how the system responds and recovers. While its value lies in testing resilience, it can also reveal vulnerabilities, especially in systems critical to healthcare. You'll see these two methods, in our examples later. The strategies we just explored can be categorized into a taxonomy of automated testing approaches. This taxonomy organizes the methods by their focus areas and objectives, which helps in strategically applying the right testing method for the right use case. Let me quickly highlight each category. Functional validation focuses on ensuring individual components work as intended and continue to function after the updates. From our list of methods, this includes functional testing, regression testing, and chaos testing. Interface and data exchange ensures the seamless data flow between systems, which is critical for an interconnected healthcare ecosystem. And this includes our integration testing and interoperability specific testing. Performance and reliability tests, they test the scalability, efficiency, and resilience under varying workloads. This includes our performance testing and then also the load and stress testing from the previous slide. Semantic validation and compliance testing addresses the unique healthcare requirement of consistent and meaningful data interpretation while adhering to the standards like FHIR or HL7. And this includes semantic validation and compliance testing. Security and risk mitigation testing, they test the safeguards sensitive to healthcare data by identifying and addressing vulnerabilities. In our list, only security testing falls into this category, but I could also see things like AI-led penetration testing as another method that could fit into this category. And then there's workflow and scenario-based testing, which validates real-world workflows and operational scenarios that ensure clinical processes function smoothly from start to finish. And this includes things like end-to-end testing and scenario-based testing. These categories provide a structured framework for applying automated testing in a way that's tailored to the specific challenges and priorities of healthcare interoperability. Now that we've categorized testing strategies, let's take a closer look at the criteria we can use to evaluate their effectiveness, especially in healthcare-specific contexts. These measures are tailored to the unique needs of healthcare systems, addressing aspects like patient safety, regulatory compliance, and data integrity. Most of these are scored in a pass-fail capacity and then are evaluated in aggregate to get an understanding of how the testing strategy would perform in a healthcare environment. So here's the evaluation criteria. There's the clinical workflow accuracy, which means does the testing method validate critical workflows such as patient admissions or medication ordering? This ensures that the processes remain reliable. There's the interoperability compliance. Is the system adhering to industry standards like HL7 or FHIR? The patient safety impact. Does the testing method identify areas where errors could directly impact patient care? Data integrity validation. Is the data exchange complete, accurate, and unaltered? Semantic consistency. Does the system interpret or use medical terminology uniformly across the platforms? Regulatory compliance assurance. Is the testing aligned with healthcare regulations like HIPAA or ONC, which has a validation or a test that they do on applications? The real-time testing capability. So how well does the test handle real-time validation under time-sensitive scenarios? Error propagation risk assessment. So that means what's the potential for downstream impact of a system failure? And we rank this one on a 1 to 3 scale, along with the real-time testing capacity and the impact on operational efficiency are all measured on 1 to 3 instead of the Booleans. There's the healthcare data sensitivity. So does the testing secure sensitive data like patient diagnoses and lab results, and then impact on operational efficiency. So does this reduce the clinician's burden or streamline workflows? This is measured in that 1 to 3 scale as well. So each of these criteria provides a lens through which we can assess and prioritize testing efforts. For example, systems that manage sensitive patient data or high-risk workflows would require rigorous compliance and safety validations. So these measures ensure that we are not only testing for the sake of testing, but we're also strategically aligning efforts with the healthcare priorities. So this is an example of how you would do like compare functional testing and chaos testing. So this is like the two that we went through earlier. So they're using the taxonomy and then the healthcare specific measures. So the idea is that you would measure within a category each of the different testing methodologies to pick the best one for that category. Functional testing aligns well with healthcare's needs, so it validates critical workflows like medication orders, lab results, while ensuring compliance with standards like FHIR. It directly supports patient safety and data integrity, making it a strong candidate for functional validation. In contrast, chaos testing poses risks. It injects faults and then disrupts the workflows, which compromises safety, exposes sensitive data, and then also makes it unsuitable for live healthcare systems. So the key takeaway here is functional testing is ideal for automation in healthcare, whereas chaos testing is a poor fit due to its risks and potential for patient harm. So now that we've identified the right testing methodologies to automate, the next step is to prioritize where we can target those efforts. So not all API regions carry the same level of risk. Some like those handling medication orders or allergy data are highly sensitive and safety critical, while others like room assignments or like patient arrival time has much lower impact on patient care. So to guide prioritization of where we're going to build our tests, we use a risk assessment framework, so that evaluates the API regions across multiple criteria. I'll just walk through a couple of these. So there's the patient safety impact. So does the API manage safety critical data like medications or orders? So high risk areas get a score of 3, there's medium gets a 2, and then low gets a 1. Does the data, so regulatory compliance means does the data comply with standards like HIPAA? And so then, of course, high compliance critical data is then ranked higher. There's the error propagation risk. So if something fails, how far does the error ripple throughout the system? APIs with widespread effects score higher here. And then there's like a change frequency. So how often does the API or its underlying data change? Frequent updates increase the likelihood of errors and then also then score higher. By change frequency, though, I'm talking about like applications as they get upgraded or modified from version to version. So this framework accounts for secondary factors like interoperability dependency and developer understanding. Also, to ensure that we are capturing a full spectrum of risks. So these measures are then put into a weighted formula to calculate the overall risk score for each API region. The formula you see here incorporates all the criteria we just discussed, but each is weighted to reflect its relative importance. So for example, patient safety impact and regulatory compliance each have higher weights, increased by 50% over the standard, because they directly affect patient outcomes and adherence to legal standards. Other factors like financial impact and workflow criticality also carry significant weights, emphasizing their operational impact. Lower priority criteria like developer understanding or the superfluous nature of the API area are assigned a lower weight, just half even, since they have a less influence on the overall risk associated with that API. The weighted scoring ensures that the most critical API regions, those with the highest potential for harm or disruption, are prioritized. By aggregating these weighted scores, we can then produce a risk score that helps identify where the automated testing efforts will have the greatest impact. Ultimately, this formula is more than just math. It's a structured, data-driven approach to decision-making, ensuring that resources are allocated appropriately to safeguard both operational efficiency and patient safety. And so this table shows how the risk assessment formula helps prioritize testing efforts by scoring API regions. High-risk areas like allergies and orders placed, orders being like medications or procedures, they require focused automation due to their critical role in patient safety and workflows, where the low-risk areas like room assignment or patient arrival time can receive less emphasis. So the result then is a clear strategic allocation of resources where they matter the most. By combining the taxonomy and then the healthcare specific criteria and then the risk assessment measures, we can make informed data-driven decisions. For instance, this approach highlights the need to prioritize automated testing, automated functional testing specifically, for critical areas such as allergies and order placement. These components also have the greatest impact on patient safety and workflow integrity. So some weaknesses and area of future development. So this study, while robust, is not without its limitations. First, the framework is primarily theoretical, and there's a need for real-world validation. Second, empirical validation is limited, which makes it necessary to test the proposed measures and the risk assessment in practical settings. And then finally, the API regional risk scoring is subjective at this point, which could introduce variability in its application. Though this is intended to be used as an assist to analysis, so the subjectivity is like a minimal issue. To address the weaknesses, future work should focus on three key areas: conducting real-world case studies to validate the framework, developing standardized tools tailored to healthcare-specific criteria, and then exploring machine learning applications to enhance the accuracy and efficiency of the API risk scoring. So in conclusion, this study delivers a comprehensive framework comprising of a taxonomy, healthcare-specific criteria, and then a risk assessment model. Together, these tools provide actionable insights into improving automated testing efforts in healthcare interoperability. The framework remains healthcare focused, aligning with the critical priorities such as patient safety, compliance, and operational efficiency. And then some key takeaways I'll leave you with are, they include an emphasis on the importance of optimizing limited resources through targeted testing efforts, and then the need to advance healthcare interoperability by leveraging robust and strategic frameworks. Ultimately, this research contributes to the building of resilient, safe, and efficient healthcare systems that are better equipped to handle the complexities of the modern interoperability. These two slides are the references I used to build the background and then the justification for the study. I'll briefly pause here on each slide to give you a chance to pause the video if you're interested in exploring these sources. And then here's slide number 2. And then this is normally where we'd ask questions. However, you can reach out to me at my email address or use the QR code to reach my LinkedIn page. And of course, you're welcome to visit me in Madison, Wisconsin. Thank you for attending this talk.